Optimization example 2. The cylinder shown has a base radius r and a height h. The cylinder has a volume of 500 pi centimeters cubed. We want to find the dimensions of the cylinder that minimizes the material used to make it. Well, for a cylinder, the volume is equal to pi r squared h. So 500 pi would be equal to pi times r squared times h. We don't know r and h at the moment. Cancel a pi off both sides, and that gives me r squared h is equal to 500, and therefore h is equal to 500 divided by r squared. And let's leave that there for a moment. It gives us a relationship between our two variables, though, h and r. Now, the surface area is the amount of material used. Now, we've got two circles, a top and a bottom, so that's 2 lots of pi r squared. And then you've got the curved surface of a cylinder, which is 2 pi r h. Now, we can't differentiate at the moment because we've got two variables. But we know that the h can be replaced by 500 over r squared. So that's going to be 2 pi r squared plus 1000 pi over r. We can write that as 2 pi r squared plus 1000 pi r to the negative 1. So ds dr is going to be 4 pi r, take away 1000 pi r to the negative 2. And we need that to be equal to 0. So that would mean that 4 pi r minus 1000 pi r to the negative 2 would be equal to 0. And of course we could rearrange that to put that on this side like so. And then pi's will cancel out. And if we bring that up here, we've got r cubed, and 1000 divided by 4 is 250. So r is going to be the cube root of 250. So we just need to grab the calculator for that. So just clear what we've got there. And is there a cube root button? I think there is actually. So just there, cube root of 250. So about let's call it 6.3. So let's use an approximately equal to. And that's in centimeters. And then we can use that to go ahead and find h from here. So h is going to be approximately, and grab the calculator again, and that would be 500 divided by our last answer squared. So about 12.6. So 12.6 centimeters.